Hello and welcome to another episode in the Sendycar Design and Make series. This week I'm talking intake plenums. I'm going to take you along the design and development process of making an all-new intake plenum for this bespoke 2.3 litre V8 being made by Prototipo over in New Zealand. Because this engine is the only one in existence, that means there are no intake plenums currently designed for it. So I get to do a ground up build essentially. With that comes some upsides in that it's a complete clean sheet design and I can adapt it fully to the Sendycar. The downside is it's a complete clean sheet design that I have to figure out exactly what I go and need. So the first thing I had to consider is actually the general layout of the car. It has ended up being a single turbo with this turbo sat behind the engine on top of the bell housing. This wasn't the case initially, it was a twin turbo at that point. So this plenum actually got adapted around the change in general vehicle layout as well as us focusing on it specifically. The other thing we were looking at originally was whether we should go to water to air or air to air intercooler. Our general analysis showed us that an air-to-air intercooler was going to be simpler and lighter, so we were proceeding with that. So knowing that it's an air-to-air intercooler and there's a big single turbo, that means there's only one charge pipe going into the plenum itself. That's quite an important feature. So next up is going through and benchmarking a couple different examples and seeing what we thought was going to work well and what we thought we wouldn't need in this case. So let's jump into some examples here. What we have here to start with is based on a rallycross engine. This is a series where they use a lot of boost and response is king there rather than peak power because turbos are running under restrictors. So what we see here is actually an intake tube going into what's called a diffuser, and this gradually reduces the cross-sectional area as it goes along the length of this plenum, which is this volume below it. Now, this is done to go and try and balance out the flow over all the cylinders whilst giving up a little bit of flow, because it adds a bit of a flow restriction to it. So when you add a restriction, it balances out the flow, but conversely, it limits the flow. So in these high boost applications, that works well. However, we felt for what we were doing, needed maybe, a little more flow than just this pure restriction. You can see here on the inside of the plenum, again, you can kind of see the intake here and this diffusing over the width of this intake plenum here. The trumpets are inside and it would come out, the air would come out in this slot below it. Next up, and this was when we were considering the twin turbo layout, was this the Bentley Speed 12, I believe, the Le Mans car, LMP1 car from couple decades ago. This was a twin turbo layout, and what we looked at was two separate intake plenums. There's a slight match left to right there, but ultimately it's two intake plenums and it combined this diffuser going into this small plenum volume. So that was maybe our initial thoughts of how we should go about going and doing this. The other things we looked at were IndyCar engines. This single turbo behind the engine layout is what they've been using for several decades now. However, they're not using an intercooler, so they get a really short intake run from the turbo into the compressor outlet to the intake of the plenum. But because they're not intercooling, they're relying on both low boost and methanol to cool the charge, where that simply isn't an option for us, unfortunately. So this is a very early engine here, maybe late 80s, early 90s. This is a later one, which I believe is a Cosworth. It's either the XD or XE. You can see here they've got more modern materials with a carbon fiber top end to the plenum, and it's a cast lower side to it. There's actually a lot of force trying to blow the top of the plenum off the engine. We worked out, I think for our plenum, it was about 300 kilos. so significant. You can see here the inside of this. Actually looks like a model by the looks of things. The inside of what the plenum looks like though, very similar to this with carbon intake trumpets, and these are aimed towards each other as well. I believe that has a scavenging effect as well as a nice tight package, which these IndyCar engines had to consider because of their very low cross-sectional area, very streamlined cars. And here's another example of that, another IndyCar by the looks of things. Again, a big volume with the plenum going on top of the engine, and then the intake from the rear of the plenum because of the turbocharger. Again, this is not available to us, but you can see here there's a few modern pieces added to this setup. This looks like a bit of a resto mod rather than the original equipment back in the day. It's like a regular Bosch throttle body there. So that was some benchmarks there for us. Pretty interesting. What we kind of knew from it was we wanted a reasonable plenum volume for good power and performance. We also wanted to ensure that the flow was going to be balanced over all the cylinders, and then we could also consider the tight package that we saw in IndyCar and how we're going to have to route our cooling tubes or air tubes going to the plenum itself. So really helpful in that regard. With this, we made some initial concepts in CAD, which we'll jump back into and take a look at. You can see here, this is our first stab at it. It's got a secondary fuel rail as well on top here with the fuel cone modeled, and then with an intake on the end. This is very much the bare minimum that we were thinking of when it came to a plenum. It had a good volume, intake towards the back. What we were worried about here was the air coming in was going to go across the spray cones, potentially blowing them into the cylinder next door. So that was another feature we were considering with the air coming in the plenum. So with that initial idea, we put that into the back of the car, and actually you can see here is this was back when the car was a tube frame and the initial engine package was getting laid out. And then, yeah, you could see here, this is sketched in red, how we were going to take the air from the twin turbos to this plenum setup. The separated plenum is nice because it can remove effects that you might have how the two sides interface with each other with the twins. However, conversely, then you have essentially you're running the engine like two separate banks, which comes with some added challenges there. So I don't think it was important as maybe we first thought. You can see here though with how this was sitting, it was sitting quite wide even though it's quite low, and that was coming out towards the edges of the bodywork here and also hitting these cage frame rails as well. So yeah, a couple of headaches packaging wise there. We saw that we needed to narrow it up a little bit. And then here you can see that when I went over to the Tatus tub, this is now the Tatus package, and we went to a bigger, boxier, larger air volume style layout, which you can see on top here. But the physical space this was holding up was proving to be quite a large challenge in the end, so causing some issues really. But this is, you can see now with the single turbo layout, how that's all sitting. And yeah, a view from the other side, this was, the twin turbos where they were going to sit all the way up there on the right versus the big single in the back. So I think this was a much neater package in that regard. So this is what we were looking at development-wise. It still wasn't quite hitting the mark, I don't think, packaging-wise. And then we also considered the length of the inlet trumpets and where we wanted the torque curve to be. The philosophy around this engine's always been focused on, it's a high revving power monster, but then we've got to turn that into more of a torquey engine. So that's where we want slightly longer intake runners. So we were considering that, and that also helped us from a vehicle packaging if we kept them longer, if we curved them in at the same point, which is actually similar to that older IndyCar style layout. So with that, we came up with a concept and printed it out in plastic for this period of time, which have these intake runners coming into this central volume of air essentially. So, and all these, intake runners which house the secondary fuel rails on the top, that was, they were separate parts compared to this main volume. And then we took an intake in from the the front of the engine essentially. So we ran this on the NA engine with the plastic plenum just to see some of its torque characteristics. What we found was it did give up actually quite a good bit of peak power, but it did help torque in the mid-range. So again, this is what we're looking for. We can always push the turbos harder at the high end to make that peak power that isn't as hard, but getting the response in the mid-range, I think, is key, because on the mountain you're really struggling for exhaust energy. So anything you can give to the mid-range will really help the performance of the car, both coming off the turn and also spooling the turbo. So at this point, we were looking at all the different materials we could go and use. We were considering casting, we were considering CNC machining, we were looking at 3D printing, maybe even out of plastic. There are a few high temp nylon carbon fiber reinforcings that could have maybe done it. But we came upon 3D printing aluminium. So we got the main body here, and we got the end cap, and then we have the feed tubes as well. And you can see some of the internal geometry in here, and it's essentially a bit of a diffuser that runs through this main intake channel into each individual cylinder. So a little bit of a restriction there, but still reasonably open. And then there's a good air volume underneath it to, essentially give, make the plenum work as an air volume. And you can't see it here, but there's a central rib here that supports the whole piece structurally, but it also allows, air pulses to go from side to side as well. So that means we can have all the cylinders interacting with each other in terms of airflow. We have a light diffuser going in here that is doing its best to spread the air evenly over all the cylinders. So this is what we came up with. And then we go and look at it in CAD with the whole rear end package of the car. You see it looks pretty neat. We've got all these hexagonal structures on the top of it, which helps essentially with the stiffness of the part. So we can maintain a very thin wall thickness, but then add a bit of structural rigidity all over the whole piece. And that, combined with the internal ribs, went to go and support the whole thing. As I said before, we calculated about 300-400 kilos of force trying to blow this plenum off of the engine, which is significant. So that's, one of the big forces we had to consider reacting against. And we have these mounts here that go and hold the plenum down. We've got the air temperature and air pressure sensor on the back there as well. And then we're using a Wiggins clamp on the front here to connect to the boost tubes themselves. So a pretty neat looking piece, I think. Taking advantage of the 3D printing technology. The most common question I get is how that must be really expensive, and actually it ends up being cheaper than all the other methods when we're looking at 1Z, 2Z parts. So it's incredibly powerful manufacturing method to go and do some really crazy things, especially with this very bespoke, high-end, high-performance style car. So I'll go into a little more about 3D printing and generative design in another video, but for now I think you can see it makes a pretty neat piece on the car. There you have it, an in-depth look into how we came up with this crazy looking intake plenum. Really excited for it to run on the dyno with the turbocharger. That is getting, it's been installed at the moment. So that should be running within the next couple of weeks, and we'll get some really good performance numbers from that. So looking forward to sharing that with you coming up here. As always, huge thank you to Prototipo. Absolutely fantastic company that share my passion of going and doing crazy things and looking to the future and taking a few risks. And that's, because we're being smart about it. So not crazy risks, but calculated risks. And I think with that, we've got a really great engine package. So looking forward to having that run on the dyno and sharing all that information with you. Don't forget to like and subscribe, and I'll catch you in the next one. Goodbye.